Hello everyone, welcome to my class. Myself Trishita Ghosh from Department of Information Technology, Guru Nanak Institute of Technology, Kolkata. In this lecture series, we will learn about the subject data structure and algorithm. So, first, what we should know that why we have to study this subject. So, first of all, I have to tell that it is very important subject for a information technology and computer science student, because you know that today is the era of data. There is data everywhere, and we have to store that data in such a way that we can retrieve it easily. So we have to store the data in efficient way so that we can get it whenever we need all this. So today we will learn about the introduction part of data structure, where the table of the content is definition of data structure we need to study, and next it will be the classification of data structure, then primitive non-primitive data structure, linear non-linear data structure, what are the operation we can do in the data structure, then what is the algorithm, and then the abstract data type. So first topic is what is data structure. So before knowing this, what is data structure or the definition of data structure, first we have to know what is data, because our subject name is data structure and algorithm, and we have to know all these three letters. Okay, so what is data? Our first question is what is data? Data means a simple value or set of values. Means anything, any value may be called as data, and we have to process this data so that we can get some information from that. Suppose we have a set of data of a college student, of some of the college students, you may see their roll number, their name, their address, their semester marks, all data we may have. But if we don't store that particular data in an efficient manner, then we can't find it out easily from the database. So we have to store that data of the student so that we can get the information for a particular student. So this is called information, means the processed data is known as information. Next, we are going for data structure. Data structure is the logical and mathematical model of particular organization of data. Means for an organization, if we have some data, we have to store that data in some logical or mathematical way so that we can get it easily. Okay, so this is called data structure. What the picture says that there is different kind of data in the world, and we have to store that data in a efficient manner. Next is a classification of data structure. Mainly there are two kinds of data structure. First one is primitive data structure, and second is non-primitive data structure. Under primitive data structure, as we know, and this subject for this session, I will discuss about the data structure using C language. Actually, means we will implement the program using C language. So what are the primitive data structure for that? That is integer, float, character, pointer. This kind of data we can store in our system. Means suppose we need to store the roll number. it will be the integer type of data. Suppose we need to store the marks of the student. There may be floating value for that. Character, the name will be stored in character format. Pointer, suppose we want to store the data which are linked with each other, then we can use the concept of pointer. So those are the primitive data structure we will study. Then the non-primitive data structure, under which there are two kind of data structure, and those are the main part of the syllabus of this data structure subject. So first is the linear data structure, under which we have array, linked list, stack, queue, all these things. And last one is the non-linear data structure, where we have to study tree and graph. So the classification of data structure can be like primitive and non-primitive. Under primitive data structure, we have integer, float, character, pointer, those data type which we can use directly in machine, and means which machine can operate directly. And the non-primitive data structure, it is linear and non-linear data structure. Under linear data structure, we will study array, linked list, stack, and queue. And for non-linear data structure, we will study tree and graph. We will study all this in brief in the next part of this lecture. And for now, we have to know what is primitive data structure and what is non-primitive data structure first. So primitive data structure means those are the basic data structure that are directly operate upon a machine instruction. I mean, suppose we have written int a. Int a is written. Suppose we want to do the summation of two numbers. Then in C language, what we will do? First, we have to write hash include stdio.io.h. Then we have to declare some variable. Suppose a and b are two variable we need to declare. So this int a will be written, then int b will be written. After that, we have to take some variable where we have to store the data. Now we are doing average of two data. So what we need to do? Then the average may be in float value. So int a, int b, then float c we can declare. Okay. So what we are doing? We are declaring the variable type int a, int b, whatever it is. It can be directly operate upon the machine instruction. So those are known as primitive data structure. And next one is the non-primitive data structure. Non-primitive data structure means always it will be derived from the primitive data structure. It will be derived from the primitive data structure. Whatever we will do for this non-linear data structure and linear data structure, those are the non-primitive data structure. Means to declare for as I have to take consider that you all know the C language, so that we can say if we have an array, so how we can declare an array? That must be, suppose it is an integer type of array, as array can store the similar kind of data, and we have taken int array 5, means this array can store 5 number of element, means that is the size of the array which can store 5 integer value, because array can store the homogeneous data. But whenever we are declaring this array, before this array name we have this type, data type, means int. Suppose we have to store the float kind of data, then it will be float. If it is character, then it will be char, like this. So what we are doing, we are using this int. We are using this int, which is a primitive data structure. We are using int, which is a kind of primitive data structure. Okay, means we are deriving this array, the declaration of this array from this primitive data structure. That's why this is known as non-primitive data structure. It means non-primitive data structure is always derived from the primitive data structure. Okay, so next is linear and non-linear data structure. Now, these two classification are under non-primitive data structure. Means we have to derive this data types from the primitive data structure. So linear data structure is a data structure where data elements are arranged sequentially or linearly, where the elements are attached to its previous and next adjacent. It's called linear data structure. Now, what is the meaning of this thing? Suppose we have 10 friends and we are holding each other's hand. So what it will be like? It will be like a line, or whenever we are standing in a queue of a ticket counter, then always we have to be in sequential order. Means whenever who will come first, he or she will get his first turn. Then other have to wait for its turn. But no one can go before him or her. So there is a sequence. And this kind of data structure are known as linear data structure. Under this linear data structure, it is array, stack, queue, linked list, all are there. Okay, so linear data structure means whenever the data will be arranged sequentially, it is known as linear data structure. Next, we will come for the non-linear data structure. This non-linear data structure are not arranged sequentially. Okay, means for linear data structure, what you can say, for one element there may have maximum 2 neighbors. Suppose we are in a queue, then in front of one person there may have one, and after him or her there may have one. So there may have maximum 2 neighbors. But for non-linear data structure, there may have more than 2 neighbors. Means if we talk about an organization for an educational institute, suppose there is a group, suppose JIS group is there, under which we have considered, suppose there are 5 colleges only. Then under JIS group there is 5 colleges. Among them, GNIT is one of them, and under GNIT there are 7 different department. Okay, so what we are following, there is a hierarchy. There is a hierarchy. Okay, so this hierarchical data is known as non-linear data structure. Okay, and for a map, what you can say, there are several points from where we can go from one point, we can go from one point to another from different way. Means there is more than 2 paths to go to one point, or maybe in different point. So this is a graph, means one element may have more than 2 neighbors. So those kinds of data are called non-linear data structure. Next, we have to know what is the operation we can do in data structure. The operation we can do means we can insert. Suppose we have a list, then what we can do? We can insert some new value on that list. We can delete some value from the list. We can traverse the value, means we have the database for 30 students. For a mentor, suppose there are 30 students. Now some student has admitted, newly admitted students are there. So what the mentor have to do? He or she have to enter his or her name on that list. So insertion we have to do, means we have to insert new values on that list. Now suppose someone has left the college, or someone has left for other mentor. So what we need to do? We have to delete that student name from the list. Traversal means we can go for the details for each and every one. We can traverse to each and every one of the students' database. Then it is searching. Suppose I want to search who is the topper of the class. Then we can search it very easily if we store the data in efficient way. And there is some searching technique to get the data very easily. Then sorting. Suppose someone had asked that give your student name according to their semester marks. So what one have to do? It have to he or she have to sort the student name according to the column of the marks. So this sorting can be done by using the concept of data structure. Then merging. Suppose we need to know what are the average. So what we are doing, what we are merging the data first, then we are getting the average. Whatever it is, means this kind of operation can be done. This is a common operation actually, what we can done in data structure. Next is, our subject name was data structure and algorithm. We have learned the introduction part of data structure. Now we have to know what is an algorithm. Suppose someone have asked you to prepare tea. So what one will do? He will first take some water, then give this add the sugar on it. Then he or she can add the tea leaf. Then tea can be prepared. Other one can do, he or she can add milk also. One can't add, or suppose he or she don't prefer sugar, then he or she will not add sugar. So what I want to say, the tea preparation is a problem, and this problem can be solved in several ways, but there are some steps to solve that particular problem. So, and these steps are known as the algorithm. Step-by-step approach to solve any problem is known as algorithm. So next, what we have to know, what can be, if there is several ways to solve a problem, then what will be the good algorithm? A good algorithm depends on the correctness and efficiency. Correctness means we have to give the correct input, then only we will get the correct output. And the time of solving the data, it must be less, so that we can say that it is efficient one. Suppose whatever problem was given, tea preparation. Suppose we have added salt on that tea, then what will happen? It is the wrong input, so it will not give the correct output. This is called correctness. Okay, so next example, what we can say that there is a truck, and there we have 9 point to visit. This point we have to visit, and we have to return to point 1 once again. So the truck is going from 1 to 2, 2 to 3, then 4, 5, 6, like this up to 9, and then this will return to its destination once again. What was the source? That is 1. So now see, if these edges are the distance, then what we can say, 3 is near to 5. Then if the truck will go from 3 to 5, it will be easier, it will be cost effective. So we have to write the algorithm in such a way so that it will be efficient. Okay, we will not go from 3 to 4, we have to go from 3 to 5, as because we are considering these edges as distance. So first we need to go to 5, then we can reach anywhere to 6 to 4, anything, or we can go from 2 to 4, then we can go to 3 also, if those are the distance. So we have to write the algorithm so that it is efficient, means it will take less time to do the job. So this is all about the algorithm. Then we will learn about the abstract data type. It's an important term for data structure. Abstract data type, sometimes it is called ADT. It means the data and the operation, what we need to do, it will be defined to the user, it will be defined to the programmer, that what kind of operation we need to do and what data we have to take. This value will be given, but it totally depends on the programmer, that how he or she should implement that problem. So this is the problem where the data and the operation is predefined, but how to implement it's not defined. Suppose there is some data and you have to store the data according to first come first serve manner. So what we can do here, we are creating a list according to first come first serve manner. So the data and what we have to do means we have to store the data first come first serve manner, those are defined, but how the programmer will implement this is not defined. Okay, it's up to the programmer how he or she should store the data. We can in the next class we will study about linked list, array, all these things. So there we can see that we can store that particular data by using linked list concept, means the pointer concept, or we can store the data by using array also. So this totally depend on the programmer, what he or she will do. Means the implementation is not defined, but the data and the operations are already defined. So this is known as abstract data type. Okay, so this is all about the introduction of the data structure. In the next lecture of introduction to data structure, in the part 2, we will learn about the brief description of linear and nonlinear data structure, what we have seen, that array, stack, queue, linked list, tree, graph, all these things. So for this timing, thank you. If you have any question, you can write me at this email ID trishita.ghosh@gnid.ac.in. So thank you all.